Hello and welcome to DirectX 11 Tutorial 30. In this tutorial we are going to look at implementing a basic view and projection matrix. Before we implement the view and projection matrix, let's go up to our graphics header, and I'm going to change. We had it where we were passing in the width and height for initialize DirectX. However, some other things are also going to use the width and height, so I'm going to take this out as an argument and instead just have it as a member variable. We'll just call those window width and window height. And let's go up to our initialize. And what we are going to do is just set it at the beginning of this. And for initialize DirectX, we can take that out. And let's remove that from the definition. And we're just going to replace where we had the width and height with our new member variables. We also had it for our depth stencil. And we had it one more time for our viewport. Let's try to compile this just to make sure that we didn't forget anything. Okay, and it still compiles. So what we are going to do is we're going to go up to our render frame function. And if you remember before, we were scaling down our object by 50% and then scaling it by another 50%. So we were drawing it at 25% of its original size. What we are going to do is we are going to add a new matrix. And this is going to be the world matrix. And for now, we're just going to set it to the identity matrix. Now, if you remember, the identity matrix doesn't actually do anything. It's like multiplying a value by 1. So we're going to, for our constant buffers matrix, for now, we are just going to set it equal to our world matrix. And the purpose of the world matrix, if you remember from the last tutorial, it is to get the object in the world coordinates. So we'll have the object in the local object coordinates where all of its vertices are. And we multiply it by the world matrix to get it moved out in the world where it should be. Of course, since we're multiplying by the identity matrix, we are not actually moving the object. Let's go ahead and create our view matrix. So for our view matrix, we're going to need a few things. The first thing we will need is our eye position. And if you note, we are using XM vectors for these fields. Now, to set an XM vector, we are going to be initializing it with XM vector set, and we will pass in an X component, a Y, a Z, and a W. For our eye position, we are going to have it back just 2 units on the Z axis. So keep in mind we are using a left-handed coordinate system, so if we move forward down the Z axis, it will be increasing, and if we move back, it will be decreasing. So we're just moving back 2 units on the Z axis. The next vector is our look at position, and we're just going to have 0 for our X, Y, and Z, so we're looking at the center of the world. Next we have our up vector. Now this vector represents which direction is up, and we want our positive Y axis to be up. We are always going to use the positive Y as the up direction, so we will have 1 for our Y in this vector, and then 0 for the other components. To create our view matrix, we're going to call XM matrix look at LH, and LH just stands for left-handed since we're using a left-handed coordinate system. Next, what we are going to do is in our constant buffer, after we put in our world, we are going to multiply that by our view matrix. Go ahead and add view right there. So next we need to make our projection matrix. And the way that we are going to do that is first determine our field of view in degrees. We will convert that to radians by just dividing by 360 and multiplying by 2 pi. We need to get our aspect ratio, which is just going to be our window width divided by our window height. Note that we are casting these to floats because if we don't, then we will get integer division, and we would just get probably 1, since integer division will just round to the nearest whole number. Next, we are putting in our near z and our far z. And if you remember in the last demo, when our near z was 1.0, it was cutting off a lot of objects and it looked kind of strange when we got close to them. So we're going to set it to 0.1 since that's pretty close to the camera. Next, to create our projection matrix, we are just calling XM matrix perspective and then field of view left hand, and we pass in our field of view, our aspect ratio, and our near Z and far Z. The last thing we need to do is, in our constant buffer, we're going to multiply by the projection matrix. One more thing I'd like to do is go down to where we are initializing the scene. And we had our Z value as 1. Let's just move this to the center of the world. And let's debug this and see what we get. Alright, so our camera's just moved back a little bit, and we have our object in the center of the world, and we're looking at it. Now, let's say that we want to make the object start a little bit lower. What we could do is change our eye position to have a negative Y value. And now we will be below the object and looking up at it. And you see that now we're supposed to be below it and looking up. Now, what if you want to actually update the eye position? So let's say we want the eye to start low and move up. Well, the way that it works is actually kind of a pain. So XM vectors, we can technically access the different X, Y, Z, and W components by doing something like, if we wanted to increase the Y component, we could do something like this, but you're actually not supposed to access it like this. The way that you're properly supposed to access it is by utilizing XM floats. So what we could do is we could do something like this. We could do, we'll call this iPose float 3. It's kind of an ugly name, but oh, and we need to put the DirectX namespace, of course. What we have to do is we have to store this vector in this float 3. And we will do that by calling store float 3. We will pass in the address of where we want to store this. And then we will pass in the vector. Next, on our float 3, we will access the Y component. And we will increment it. And then next, we will load the float 3 into our vector. We will do that by calling xm load float 3. And we will put the pointer to our float 3. And it actually returns the vector. So we will say iPose equals, and we will set it to whatever is returned. So this is the proper way to update a vector. Let's go ahead and test this out, see what it looks like. And you see that our camera started low, and it's just moving straight up, and it's just staring at our object, and now it's just going to get farther and farther. So that is all that we are going to cover in this tutorial. In the next tutorial, we are going to look at implementing a camera class and the basics of the camera class. In the tutorial after that, we will get a little more advanced in the camera class and put in some other features.